So today I'm just gonna go over the exercises from the first lecture. Amir told me that your codes were not always optimal and you guys weren't like using C++ efficiently. So I'm just gonna go over how I would have solved these problems, go over like a few of the more useful functions, and then like how to think about these problems and a little bit of complexity analysis. Since you guys all solved it, I assume that you know the statements. And the first one is for parity sort. So I have an integer of arrays of length n, and I can swap two elements if they're both even or both odd. And I want to determine if I can sort the array. So let's look at what that might look like. So if I have an array that has 5, 3, 2, 1, 5, or something like that, I would be able to swap these elements amongst themselves. And then 2, it's the only even element, and so I can swap it. And you guys know, like, if you think about something like bubble sort, that just by swapping elements in an array, I can make it to be any array I want. So essentially, I could order these odd numbers in any order, and I could order these even numbers in any order, as long as the ending position, if they had the odd number in the beginning, is going to keep having an odd number. And if it started with an even number, it's going to keep having an even number. So essentially, right, I could, for example, here have 1, 3, 5, 5, and I could have 2. But the sorted version of this array is 1, 2, 3, 5, 5. And this will never be possible because this position here started having an odd number and it finishing having an even number. And since I can never swap an odd number with an even number, I cannot just change these values. So what I'm going to try to do in my code is I'm going to find what array I want, so the resulting sorted array, and I'm going to check for each element if the parity of the sorted array in that position is the same as the parity of the unsorted array in that position. And then if that works, that means that I can just swap the numbers around to have the final sorted array. Okay, so let me go to the code here. And now let's start talking a little bit about how to program things in C++. Hopefully you guys all get the idea of this. So first of all, I'm gonna include this library right here that you might not know. And this is just a library in C++ that has this has like all the libraries. So this would be equivalent of me doing like include algorithms and include math and include all of these things. I'm just doing them all at once because it's easier for me. And I highly recommend it. This works on code forces, so it should work for your submissions. And it's just easier than manually having to include every single one of your libraries. It might not work by default on Mac. I think it works by default on Linux. And if you have a Mac, then there's probably like some simple code forces tutorial on how to make it work. I think you just have to copy a file somewhere in your C++ configurations. But this is just like kind of a quality of life thing. You would never do this in a company because it increases compilation time. But for us, compilation time doesn't matter. And for like these small files, it doesn't increase it much anyway. And then using namespace std. This is just so I can write all the standard functions without having to put std in front of everything. It's also a bit of a quality of life thing that makes your code like significantly shorter and more readable if you're not like using a bunch of namespaces and libraries and everything. So like for our purposes, this is also like a nice quality of life thing to do. And now we're gonna define our main. So let's look at the problem. First of all, in this problem, we have a bunch of test cases, right? So first I'm gonna read the number of test cases. And this is how I usually implement it. So this is a feature of just like how C++ converts integers to booleans. Once you convert it automatically, if the integer is greater than 0, it's gonna return true, and if it's 0, it's gonna return false. So here, for example, if my t is 5, I'm gonna return 5 and then decrease it to 4, and then return 4 and decrease it to 3. So this is just a loop that runs c times. It's a little bit faster to write it than a for loop, and it doesn't waste a variable. So that's just how I usually do it. But again, it doesn't really matter much. So now we read the number of elements in our array, and I'm gonna declare a vector of size n. Here, I mean, I declared a vector. You could have used an array. The nice thing about vectors is that they have these dynamic sizes, and an array here, you can also declare it. It's like you can just append things to vector. I just think vectors are the normalest thing to use in these situations. If you declare like an array globally here, you could also declare an array here. And then it has to have static size, because when you declare things globally, they have to have static size. And I could also declare an array in here. So I could do something like this. And why I don't like declaring arrays inside of my functions is that when you declare something and it's within a certain scope, it's not necessary that every entry will be 0. And worse of that, it's undefined behavior. So if you do it on your computer, it might be initialized as 0, but then you run it on the Codeforces server and it's not initialized as 0. So we want to avoid undefined behaviors as much as possible, because it leads to a very frustrating situation in which your code works on your machine, but it doesn't work on Codeforces. So I don't like doing this, but when you initialize an array, when you initialize a vector like this, I know that all the entries are going to be 0, or whatever the default value is for that type. So for Booleans, it's going to be false, etc., etc. And then here I'm going to look through the array and just read every value it has. Another thing I could be doing is I could initialize the vector as empty, and then I read each element individually and I just push back it to the vector. That's also fine. That also like has no problems in terms of behavior. It is a little bit slower than putting the array with a set size and then reading each element, because pushing back things in an array takes a long time. And then another thing I'm gonna point out is that I'm using cin, and cin is slower than scanf. If you're coming from C, you're probably used to scanf. And if you're comfortable with scanf, you can use this. I like cin just because it's a little bit more convenient, but it doesn't really matter. The problem with cin is that it is a little bit slower, and when you're reading a lot of data, and in some Codeforces problems, that is a problem. But there's a way to make cin about as fast as scanf, which is using these two commands. If you put this here, like in the beginning of your function, then they are about the same speed. This is because the reason why cin is so slow is that we need to like sync the stream of input with scanf all the time, and this syncing takes a lot of time. So when I do this, I say basically like, hey, don't care about syncing with stdio, which stdio would be something like scanf. This also means that if you put these commands, you cannot use cin and scanf in the same code. I generally wouldn't recommend you to do that anyway. Like, it's better to be consistent and stand with something. But sometimes, like, even for me, using scanf is more useful because it has like the built-in parsing. But if you want to use cin and you don't want it to be slower and you're stubborn like me, this is like a good preamble to have in the beginning of your main function. Cool. So this is how I'm just reading. And then now I'm going to create a copy of the sorted array, right? Because this is what I want to do. So I'm going to do this. This is also another benefit of using vector, because we can just copy things this simply. While in arrays is a little bit weird. If you don't do it carefully, you're going to be looking at the references and pointers. And I personally like to avoid thinking about references and pointers as much as possible, just because it's easy to get confused and to get like weird errors. So when you just copy vectors, you don't have a trouble with that. You're just copying an object. It's the same as copying an integer. Well, like if you do it wrongly with a vector, you might just be copying a reference. And then when you change things, they're going to change somewhere else, and that's not nice. And then I'm going to start it. This is just the standard C++ start function. And the important thing here is that you use the C++ functions, and we're going to see this in the next problem, where I'm going to abuse a lot of the standard C++ like data structures. And you should abuse of the standard C++ data structures. Don't write your own sort. There's absolutely no reason for you to be doing this, unless like for practice, but even then, like do it in a separate file, and then just for your code, just use the standard functions. Please don't implement your own sorting algorithms. Please look if there's something in the library that can do that for you, just to make your life easier, and it minimizes your chance to do a mistake. Okay, so now like it's the actual solving of the problem, right? We want to find if there's a part of the array in which the parity of the sorted array is different from the parity of the original array. So I'm just gonna iterate through it. And then how do I check if something is odd or even? I can just take modulo 2, right? You guys should be familiar with the modulo operator at this point, hopefully. And then in this case, we set it as bad. Let me make this a little bit wider just so you guys can see the whole code. Cool. And then if, so here, my variable bad is going to be set to 1 if I have found a thing that does not coincide. So if bad, then it is not possible to do the sorting the way I wanted. And then otherwise it is possible. So I print yes. So this is what our code for this problem is going to look like. Here's the whole of it. Let's check that it compiles, because who knows. So I am using a C++, let's say 17. I don't actually use anything from 20. You guys use the version you want the most. I would recommend using at least 17, because then you get auto and you can iterate through elements a little bit easier if you like that. Okay, let's see what's wrong here. Oh, okay, I just put a different name here. Let's call it vSorted instead of sorted. Yes, now. Okay, now it compiles. Let me take the first, the test cases from code forces. Yes, yes, no, no, yes, no. That seems good. And now let us submit it here. I will just copy this code and submit it using this, because it's a little bit easier here. Now I need to log in. Yes, okay. Okay, and it accepted. Nice. So now let's go to the next problem, which is this equal frequencies. And this problem is like considerably more complicated. Okay, so we have a string and it has like a certain amount of letters. It's just a string. And I want to see what's the minimum number of letters that I need to change so that all letters appear the same number of times. And here in this problem, we're going to take a little bit of a brute force approach. It's very nice that there aren't many letters. So most problems that use strings will use that fact somehow. So here, having the number of times every letter appears and how many different letters there are is equivalent, because we're going to maintain the size of the string in the end, right? So the sketch of our algorithm is going to be something like this. Let's we're gonna first of all iterate through number of letters. And now I know, for example, that there will be like 5 different letters, right? And I want to know which letters I'm going to change into other letters and which letters I'm going to keep. And if I want to minimize the number of letters that I'm changing, I'm going to keep the letters that appear the most often. So for example, I can start a string like start the frequency of letters or something like that. Get the K most frequent. And then this number of letters that are going to appear in our string will also determine how many times each letter appears, right? And so what I'm going to do is that if a letter, for example, should appear 4 times and it appears 5 times, I'm going to replace one of those occurrences. And then if a letter, you know, appears 3 times and it should appear 5 times, I know that I'm going to have to like add 2 occurrences of this letter. And if a letter appears like 2 times and it should appear 0 times because it's not one of the letters that I selected here, then I'm just gonna replace it with something else. And then hopefully like these numbers will all coincide, right? Like the number of letters I need to add needs to be the number of letters that I need to remove, but that's just natural. But yeah, implementing this is gonna be a little bit more of a pain. I don't exactly know how you did it. I couldn't see your codes. But what I'm gonna try to do is I'm gonna try to abuse all the C++ like standard data structures and functions so that we can make our lives easier, and then you guys can also get familiar with all the things, all the beautiful things that C++ can provide us. So I'm going to start the same way. The trusty bits library and in our namespace. I'm going to define our main function. And I'm sorry, I just keep checking on Zoom that everything is working as it should. Yes, okay. Yes, okay. And then this one also has a bunch of test cases, so I'm going to do the same thing I was doing before. And then read the So string is essentially the same as a vector in C++. It's basically, it has like some extremely minor differences, but it's basically a renaming of a vector of characters, and you should treat it as so. So for example, it is mutable, which is not the case for every language, so we can change characters in a string. Okay, so here, and now I need to like iterate through all the possible number of times that the letters will appear, right? Like how many different letters I'm gonna have. I'm always gonna have at least one letter, and I can have at most 26 because I believe that is the number of letters there are. And then the important thing here is that like this is gonna be generating lots of possible answers, and I want the best one of them. So I'm gonna store the best answer here. Just because I'm gonna be taking the minimum of all the answers, I'm gonna initialize it with like an impossibly bad answer, in which I need to change like more characters than the string has. And I'm also gonna start somewhere what is the best answer, just so we can print it in the end, right? And then I'm gonna do something here. These are gonna be my best values, and then I can here just print the. Oh yeah, and this is I didn't talk about this in the last problem. This is at line. This outputs a line break, and it also flushes. You can also make it not flush, and the syntax kind of changes that. But by default, every time I print something, it flushes into the standard output, which also takes a lot of time. So for example, if you're using printf, what you're going to notice is that like while your program is executing, it's not printing anything, and then by the end it prints everything. That's because it's not flushing, like it's not working live. While this flushes it to your output, so whenever you print an end line, that thing that you just printed appears in your terminal, even like if the code is still executing. So if you are outputting a lot of things in different lines and you're like using a line a lot, that also takes a lot of time. So if you don't want to risk it, you can use this. And this is just a line break, but it doesn't flush. Here I'm just going to be using end line because there's no reason not to use it, and I think it's cuter. Cool. So now let's do what we're going to do here in the inside. Okay, so first of all, I want to, well, there are cases in which it's just impossible, right? If I cannot divide it evenly into I letters, So if this, like if it's not a divisor of I, then I just return immediately. Or if I want more letters than I have, because I need to have one of each letter, right? So in these cases, I will just like continue. I will not execute this. Let me do this so it's more readable. Okay, now we want to solve the problem. First of all, I'm going to count the frequency of each character. So for that, we can use the standard C++ data structure map. You don't need to implement your own map. Please don't implement your own map. That's a terrible idea. We're just going to use the frequency. There's also another maps. This map here technically is lower. Sometimes it's faster. If we're really getting into the gritty of it, you should know like all the variations of all the grid data structures. You might want to use an order map. You might want to set like the constant factors in the beginning if you know about how densely you're going to be filling it. But for like these simpler problems, there you won't require you do anything too fancy. But if you really want to get deep into it, it's good to know. Okay, so we're going to iterate through the here. And like this is, for example, like an iterator. So I'm just iterating through the characters of S. And this is the type of stuff that I said that I need C++17 for. I think this doesn't work in the previous versions. And it's just like a very useful, tiny thing to do. And then I just increase the frequency, right, in the map. Oh, and this map is also initialized with 0 when you're mapping to an integer, kind of similar to how vectors are initialized by default. Cool. Now I'm gonna store in a vector the frequency of each character. This is how I'm gonna get the ones with the most frequency. So and how do I iterate through the characters from A to Z? Well, interesting thing is that their codes, like their char codes, they are all adjacent to each other. So they start with A, and A is some number that I don't know by heart. And then B is going to be the number +1, and then C is going to be the number +2. So a nice way to cast, like, to iterate through the chars is to, I could just have made a chart here and like actually directly iterate through it. But this is just like useful sometimes when you're using like both integers and so I'm just gonna add J to A here. But I just noticed I could actually just, and this is like, because here I'm indexing by an integer and here I'm indexing by like its corresponding letter. So this is just like a tiny little thing we can do, because I couldn't like it directly be iterating here through chars, because in that case, I couldn't index my array. So this is just gonna be A plus J. And then another thing you might notice here is that I defined a pair. This is also like a standard C++ thing. Sometimes you might need a space here. It depends on your compiler. But a pair is a pair. I'm just putting like two different data types together, and you can access them like using first and second. If you want more than two, then you need to use tuple, and tuple have like a little bit of a different location. I don't usually use them. If you want to be a disgusting person like I am most times, you can just do a pair of pairs or something like that. And that avoids the need for tuples. But if you're a reasonable person, you should probably use tuples. So here in the first part, I'm putting the frequency of the letter, and in the second one, I'm putting the letter itself. And the reason why I'm storing the letter itself, even though I have the index, is that I'm going to store this array to get the most frequent numbers. So, and then another thing by pairs is that when you're sorting numbers, I'm going to by default sort by the first number. And then when it's the same, I'm going to sort by the second number. So if I have, for example, a pair 1, 2 and a pair 1, 3, this is going to be like 1, 2, wait, a pair 1, 2 and a pair 2, 1. 1, 2 is going to come first, and then 2, 1 is going to come second, because I first sort by the first number, and then just when there's the same, I look at the second number. Okay, so in this case, if I just sort this array, now I have my character sorted from least frequent to most frequent, right? Because by default, I'm starting from small to large. And just to fix the fact that I'm having the least frequent first, I'm just gonna reverse this array. So now the most frequent is first. And again, like just using a bunch of like standard C++ stuff so you guys can learn it. And also because it's useful, honestly, like once you're comfortable with all these data structures, it's just like very convenient to use them all the time. Okay, now I want to see which ones I'm gonna keep. So I'm gonna have a character to bool of which like characters are gonna be in my final string. Let's call me keep. And I'm gonna also create a stack of characters, which characters I need to add to my new string. So now I'm gonna get the first I characters of this array, which are gonna be my I most frequent, right? And I'm using the I most frequent because I am keeping from this loop here, I am keeping I different characters, and from what we discussed before, we want the I most frequent. So I iterate here through I, and then I know that I'm gonna keep it, and this is just gonna be a vj.second. This is the character, right? Remember that we kept it in the second position so we could compare them afterwards. So this is gonna be true. And then what I'm gonna do here in my stack is I need to store them. So since I'm gonna keep this character, I might not have enough of it, right? So I'm gonna go from the number of elements that I actually have, which is gonna be the point first here, which is the frequency of this character, until how many of the character I want. I'm essentially iterating into like number of characters I want minus the number of characters I already have. So how many characters I have to add to the final string. So the number of characters I want is s.size /i, right? If I have like 5 letters and my string has size 30, I need each letter to exist 30 divided by 5 times. And then I'm gonna put that in the stack, just so I can have a place, like a bag, where I'm storing all the strings, all the characters I need to add, and then I can add them one by one. So here I'm gonna push the character itself, which is gonna be vj.second. Now my answer, which is the number of characters I'm gonna change, is how many guys I have in the bag, right? How many guys I'm gonna have to replace in the string. So my answer is gonna be the size of my stack. And now I'm gonna create my new string. Here I could actually like check if my answer is bad, because I am keeping here in the beginning my best answer, right? So here already, if my answer is greater than my best answer, so if I will have to replace more than I already know I will have, so I can just like continue. I know that this answer is bad, so I don't need to like actually generate the string. Otherwise, this has an equal here. Otherwise, let's generate a new string. So first it starts as my original string, and then I'm gonna iterate through its elements. And notice here a difference. This time I'm iterating as a reference. I said that I avoid using references, but you can avoid them all the time. And when you're using iterators like that, you need to use references if you want to change the value. Otherwise, you're iterating through copies of that value. So for example, if I'm iterating through the characters of a string s, and I'm doing like char c in s, and I to put like c equals a, then I'm not substituting that value in x, because that char c is just a copy of the character in s. And then here, if I put a reference, for example, and if I change the value of c, then the value of c actually changes in s2. And this is what I want, because I want to find my new string. So when do I change it? Well, if there are 2 cases I want to change it. First of all, if I never meant to keep that character, right? So if I say like there will be no a's in the string in the end, and I see an a. So if I don't keep c, which is equivalent to saying like if keep c equals false, right? If I don't want to keep c, then I will set it to the top of my stack, right? I'll pick a letter that I need to put in the string in my bag, and I'll just put it instead of c. And then I'm going to remove it from my bag. Here I say bag, I put a stack, could be a queue, it doesn't matter. Could be a set, but sets are slower, so yes. And then else, if right? Set stake log and time per operation, and this takes like all of one. Okay, and the other case is if I should keep C, but I have too much of it, right? If I said, well, I need to have like 5 C's in my string, and I have 7 C's, I need to like remove these 2 C's and substitute it for something else. So if I want to keep C and the frequency of C is greater than how many I want in the end, which is s dot size, oh, I'm writing it wrong, s dot size over I, then I do the same thing, right? I just put the one on top. And also here I need to update my frequency of C because I need to remember that I removed an occurrence of C. And that's also like the fact that I'm updating the frequency array is also why I need to do it inside my for loop. Okay, so if this all works, then I already knew that my answer is gonna be better, right? So I just put that my best answer is now my new answer. And I set my new string to be S2 here. Cool, so let's run it. Let me open my terminal. Yes. And I'll take out the input here. And I'll run the same thing, but now my code is in B. Nice, it just compiles. And let's see if this works. Yes, I believe this is what should have been happening. And let's submit it. It's not like the most efficient solution, but it should be fine. It just runs on 26 times the size of the array. Okay, and it got accepted. Yay for us. Now let's do the last one. And the last one is a little bit more solvy, I guess, than necessarily coding. This is the tale of two lands. So let's look at this because now we are going to spend a little bit more time looking at the statement. And then the coding is actually pretty easy. All right, check if I have a... Yeah, everything is going fine. Cool. So this problem here, right? I put 2 markers in modulo of x and modulo of y, and then I put 2 markers in modulo of x minus y and x plus y. And I want this to be fully inside this. Let's write this down and think a little bit about the implications of what's happening. So I have x. Here's the problem, like my hand stays on the... I have x and I have y. And then I have x modulo of x minus y and modulo of x plus y. Here, the thing that important here is that these things don't have necessarily an order, right? I don't know if x minus y is bigger or if x plus y is bigger, and it actually doesn't matter. But notice that like I have the minus y here on this side, and I have the plus y here on this side. So let's say, for example, that modulo of y is equal to 5. Okay. So y could be 5, or y could be minus 5. If y is 5, then this is going to be modulo of x minus 5, and this is going to be modulo of x plus 5. If y is minus 5, this is going to be modulo of x minus minus 5, which is x plus 5. And this is going to be modulo of x plus minus 5, which is x minus 5. These have changed order, but their values are the same. This means that it doesn't matter if y is 5 or minus 5. Modulo of y is modulo of y, and these endpoints will be the same for a same modulo of y, regardless of y. And let's see x now. Okay, so let's say modulo of x equals 2. This means that x could be 2 or it could be minus 2. So here I have x minus y. So this is going to be, let's say if x is 2, it's going to be 2 minus y. And if x is minus 2, this is going to be minus 2 plus y. No. Yes, and this is going to be, I'm supposing x is positive now, right? So this is going to be 2 plus y. And if x is minus 2, this is going to be minus 2 minus y. And this is going to be minus 2 plus y. Now notice something. I want you to notice that because it's modulo, I know that modulo of z equals modulo of minus z. So we can take this minus 2 minus y and just substitute it by 2 plus y, right? I'm just multiplying everything inside by minus 1, and the modulo should be the same. And I can do the same thing here, and this would be 2 minus y. And now I have the same thing as I had with the y. So it doesn't matter if x is positive or negative. All that matters is the modulo. And for y, we have the same thing. So we can assume without loss of generality that from now on that all the numbers are positive. And then once we're reading the input, we're just going to set them to be their absolute value. Okay, so now the condition I want is that x minus y is less than or equal to x and y, which is less than or equal to x plus y. Since I am assuming that both x and y are positive, this is always going to be the case, right? I'm always going to have that both x and y are going to be less than or equal to their sum because they're both positive. So I don't need to check this. This is a little bit more complicated. So here we're going to have to decompose into two cases, right? I have a bunch of things here. I have x minus y needs to be less than or equal to x. I have that x minus y needs to be less than or equal to y. And because these are both positive, right, this is also, but the modulo can flip it. Or I have a minus x plus y, which is less than or equal to x, or minus x plus y needs to be less than or equal to y. Essentially like assuming which one is greater. So here I have y is greater or equal to x. So this is always going to be true. So this doesn't matter. Analogously, this is always going to be true. So it doesn't matter because I'm erasing something here. And now for these conditions here, these are the ones that matter. X needs to be less than or equal to 2y. And y needs to be less than or equal to 2x, right? I just threw this x to this side and threw this y to this side. So these are the two conditions we have in our array of elements. Now I need to think, how do I check how many pairs x, y in our array fill this property without actually having to iterate through all the pairs? And there are many ways to do it. I think the simplest way here is let's assume all our numbers are ordered. And I have already substituted everyone by their absolute value. So I'm going to have something like this, right? 3, 5, 6, 7. For each number, let's assume it is x. By these conditions, I have that like y. Well, I can just throw this 2 here, right? So x over 2 is less than or equal to y, which is less than or equal to 2x. Oh wait, if we assume our number Rx, I want to see the range of y's, right? So it's the same thing here. So if I have, for example, x equals 3, I have a certain number of ranges that can be y, right? I know that y is every number between 1.5. They all have to be integers here, so it's never going to be 1.5, but every number that's greater or equal to 1.5, and every number that's less or equal to 6. So in this case, it would be this range here, right? And the important thing to notice here is that if I go forward in this array, so let's say now, instead of looking at 3, I look at 5, both this number over 2 and 2 of this number are going to increase. This was actually, it was actually right in the first time. So this is x and no. Yes, I have my x and I want to find the value of y, and I know that y is going to be in this range. Yes, yes, yes. Okay. So I know that these are going to always go forward, right? Because like if x increases, x over 2 increases. If x increases, x over 2 increases. And if x increases, then 2x also increases because we're looking at the positive x's here. This means that this range is always going to go forward. So what I'm going to use in this thing here is something called sliding window, in which I'm going to keep, let's say 0, 1, 1, 2, 3, 5, 6, 7. I'm going to look at something, let's say I'm going to start looking at 0, and I'm going to keep a range of all the numbers that fulfill that. So in this case, it's going to just be 0, right? So if x is 0, my values of y can be 0. I'm going to have to subtract 1 in the end because I can't compare a number with itself, but let's pretend we can at the moment, and then subtracting it is easy because a number in itself always works. Okay. That's my 0. Now I'm going to look at 1. What happens here? Well, 2 times 1 is always going to be greater than 2 times 0. So I'm going to move this forward until I'm here, until I have found all the ones that fulfill this. And I'm also going to be moving this forward until I have excluded everyone that's less than x over 2. And then I'm going to move to 1 again. In this case, the range doesn't change. And then I'm going to move 1 again, and then this might move forward, right? This is going to move here. And it's going to stay the same. But the important thing is that every time this arrow on top moves to the right, these arrows on the bottom, they can either stay where they are, or they can move to the right as well. And then we can think about what happens like amortizedly wise. And what happens here is that if I sum all the movement of these bottom arrows, this is gonna be equal to n, right? Because I can only go right so much. I can only go right until I'm at the end of the array. So this arrow here is gonna move right at most n times, and this arrow here is gonna move right at most n times. And this arrow here is gonna move out exactly n times, right? Because I'm iterating through all of them here. So the sum of movements of all arrows is gonna be O of n. And this is how I solve this in linear time. I mean, n log n because I have to sort it, but like this sliding middle part is O of log n time, and O of n time. Let's see what this code would look like. I think this would also make the more abstract idea a little bit less abstract. Let's start by doing what we always do, which is including the bits and setting our namespace to standard and define our main function. This one doesn't have tests, so I can just read my in and then read my vector. The difference here is that, remember that I said that it doesn't matter if it's like 1 or minus 1. So every time I read a value, I will then check if it's a negative value. And in that case, I'm just gonna invert the sign. So if vi is less than 0, then I put that vi equals to minus vi. And now I need to sort it because remember, it always goes right because the numbers are in order, right? So let me sort my array. And I'm gonna put my answer. And here, this is very important, actually. I imagine a few of you guys got this wrong just because it's a very easy mistake to make. Because I am summing something that can be up to n and I'm doing it n times, even though my complexity is n log n, my answer can be up to n squared. And since my n is pretty big here, it is, let's check, can be 10 to the 5. The answer can exceed a long, right? Can exceed an integer, so I need to use long for answer. Something that I also do sometimes when I'm lazy, but that you shouldn't do, but you can do if you want, is just like do this, and then everything is a long. The only problem is like you have a problem with the main because the main needs to be int, so you can just do this, or just set void main, that's also fine. But like this is not good practice, but this is accepted. Like if you get an accepted, you get an accepted, right? Doesn't matter if you did something ugly in your code or not. So like follow your heart. Don't let people tell you what you can do. If it's working and you code it fast, just find ways to do things faster. And they work. Okay, so now I'm gonna iterate the array, right? So these here are gonna be my two bottom arrows. It's gonna be the beginning of the range in which my y can be and the end of the range in which my y can be. So first I'm gonna set these arrows to be in the correct spots. So if I am not at the end, so while my first arrow is not at the end of the array and the value that I'm looking at is less than, well, here I'm just taking, this is just like, so when it's odd, it doesn't do weird stuff. So this is like 5. So if I'm doing 5, I don't want it to go to 2. I want it to go to 3 because like this is the first number that's acceptable. So like this is just like a little hack to get the ceiling instead of the floor when I do a division by 2. So while the guy that I'm pointing to is smaller than my accepted one, I want to go further, right? Like, oh, I cannot accept this number. So I need to go to the first number that I can accept, the first number that's greater than or equal to my x over 2. So this is what I'm doing here. And so if I am not greater or equal to x over 2, I just move that arrow forward. And I keep doing that until I either get to the end of the array or I get to within my acceptable range. And I'm going to do the equivalent to the end of my second arrow, my second bottom arrow. So here, and I'm gonna get the first position that I don't accept. So the range is gonna be like closed in the beginning and open at the end. This is just my convention. You can use whatever you want. It's nice to be consistent because these things can get very confusing with the less than or equals, plus ones, minus ones, and the size of the range, whatever. I tend to default to closed in the beginning and open in the end. That's a convention a lot of people use for some reason. Right. So because remember that the arrows were pointing like between two numbers and we don't have a between two numbers here. So you just like default to, I essentially like shifted them half a position to the right. So now my first arrow points to the first nice one and my end arrow points to the first bad one. And now I can add to my answer, the size of the range. Here the size of the range is gonna be end minus beginning. But because a number cannot be paired with itself, I am gonna subtract 1. Nice. And now I will print the answer, but I'm going to divide it by 2 just because they ask for unordered pairs and like x, y is the same as yx. So I need to divide the answer by 2. Cool. Let's run this code and see if it does what we want it to do. This is supposed to be 2. Nice. So let's submit it because you don't get a penalty for a wrong answer, but you should be looking here. I was getting confused with the plus ones, minus one, minus or equal. Just normally like that's completely normal. If you're in a test, you should probably like not be getting a lot of wrong answers because in a competition, you don't want that because you get penalty for wrong answers. Here you can get wrong answers, but it's still nice to like think about it a little bit before just submitting your code indiscriminately, like I saw some of you guys did. It takes less time to just think about it instead of just submitting a lot of times. There are times when you're going to submit a lot of times and there's nothing you can do. For example, like square root decomposition, it's just hard to calculate certain symmetry things, so you're just going to be throwing constants until it works. But it's fine. Okay, I got accepted. So these are the 3 problems, and I hope I could teach you guys a little bit of how to use certain features of C++, a few hacks, and how to make code that is like more efficient. Like you can see that this is so tiny, and this is very nice. If you have any questions, you guys can send it on Canvas. And I hope this helped. See you.